In algebra 2, when you think about probability and counting arguments, you're really just thinking about an introduction. So you're really only thinking about 6 different items that could happen, 6 different things. And the first 4 are what happens if you're using up all of it, meaning you are selecting every letter in the alphabet, every kid in class. And if they're in a line, it's n factorial. If it's in a circle, it's n minus 1 factorial. If there are repeated items, like repeated letters, for instance, you would give the total and then the product of the total repeated. If you're a repeated thing over and over again, for instance, you are picking the same letters out of the same box that has the same quantity every time, that is the number raised to a power. Because like if I have 26 letters and every time I'm picking out of the alphabet, every time I'm picking it, it's 26, 26, 26. And in algebra 2, you're pretty much always going to multiply whatever you get. Now, if they are in a small group of the total, you either use P or C. P is the default. C is only used if someone says random, committee, jury, panel, or we're talking about playing cards. Notice that the word committee and card both start with a C. So at the top of this paper, I do want you to try to understand what factorial means. It just means 4 times 3 times 2 times 1. I do want you to know how to multiply that out. I want you to know how to do this and cancel. I do want you to reduce this and cancel. As you can see here, this just basically comes down to 8 times 7. So you can finish those. So then at the very beginning here, we have a little subset of different environments of these different things. Well, if I have books in a line, you know, these are all just factorials, right? 5 factorial, 12 factorial, 20 factorial, because they're not the same book. They're all different books of different subjects. And you do need to type this into a calculator or Desmos and tell me what that is. Now over here, you know, we kind of have like the same situation. We have 6 candidates and they're going to speak. Well, how many ways can they speak? Starts with 6. Then once one person speaks, then 5, then 4, then 3. They're all going to speak, so it's 6 factorial. If I selected a group, which is not what's happening, it would have been P. Think of P as limited factorial. I want 3 of these 6 people to speak. That is going to be 6P3, right? But if I want all of them to speak, it's 6 factorial. Now, you can see here that they're going to go out to lunch and sit around a circular table. That's like a key word for use, this, 6 minus 1 factorial. And of course, you want to type these into the calculator, figure out what they are. Then here we have this letters question, and this is the classic thing of like, you know, I have 6 letters in algebra, sorry, 7 letters in algebra. There are 2 A's, so it'd be 7 factorial divided by 2. But when you look at addition, for instance, you have a different amount of letters, but you have 2 D's and 2 I's. So you would look at that, 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 8 factorial. There are 2 D's and there are 2 I's. And you would just type that into Desmos. You don't have to reduce that by hand. I just did it on the first 4 problems so I can get you to understand it. Now, number 8 does cause kids problems. So let me show you what's going on here. You have 2 boxes. And in the first box, you have 4 red marbles. And in the second box, you have 6 blue marbles. And then it gives you a variety of things to think about. The first one is, what would happen if I selected 2 and I put the marbles back every time? Well, every time I selected a marble here, there'd be 4 choices, but then I put it back. So that's 4 again. So that would be 4 times 4 for the red ones. And the same thing with the blue one. If I take this marble out, I had 6 to choose from. I put it back, there are 6 again. So that would be 4 times 4 times 6 times 6, or 4 to the second power, meaning I did 4 twice, and 6 to the second power. Now the second part of the question says, what happens if I don't put them back? Well, if I don't put them back, I had 4, and then I had 3 to choose from. 4 times 3 is P. And then if I did it here, I would have 6, and then I would have 5. So that is the permutation idea. You can just do 4 times 3 times 5 times 6, though, and that would be also correct. And then the last thing is, well, what happens if I put them all in the same box? So I take all these marbles, I put them in here too. I put them in one box, and I just pull them all out. Notice the key here is I am pulling all of them out. Now, I did put the word line in there to maybe throw you off to think it was just n factorial. There are repeated. So it is n factorial. There are 10 now, but there are 4 reds and 6 blues. So it'd be 10 factorial divided by 6 times 4 factorial. 4 factorial times 6 factorial. So down here, you're just trying to figure out, you know, if is it P or is it C. You do need to go in and tell me what this is. Like, what is that, right? So you can see the key words that start popping up. Committee, use a C. Okay, believe it or not, a combination block, because the combination block is really a password, is a P. First through fourth places, that's a race, that's P, even though it's a contest. Dropping things on the floor is random, C. Password, this one would be P. Total numbers in which you order food is C, because you can't tell toppings on a pizza. If you selected 5 toppings, let's say you selected sausage, pepperoni, onion, green pepper, and olives. If somebody did that in olive, green pepper, pepperoni, sausage, you would not know. And so just make sure you put the total here and the group over here. I don't know why they don't call this a G. It's called an R. But the total is 8. I'm selecting 5. The total is 10. I'm selecting 4, and so on. Now, on the back of this, you just have a random collection of all of it. So like if I start on this first problem, you have this license plate problem, and this is a classic, repetitive issue, right? A motorcycle license is 6 numbers 0 to 9 with repetitive numbers allowed. How many are there? Well, there are 10. And if I do a license plate of 6 things, every time I select a license plate, I have the same number because I'm allowing repetition. So this would be 10 to the 6th power. However, if the second part of the problem, how many different license plates can be made for a motorcycle and a car? And in this case, they're talking about okay, so that is 6. So the car is 6 non-repeating. Non-repeating is the P. All right, so then you just have a whole bunch of them. Table is n factorial, circular table is n-1. We have the whole food thing. This is a C. This is a C. This one really gets people. For some reason, the repeated events are what cause people the most trouble. So how many different 6-digit numbers are possible if you have a tank of 50 different numbers that they select the lottery? Well, every time I go to these tanks, you have 50 choices. So 50 times 50 times 50 times 50 times 50 times 50. Then over here, if I take it out of one take, well, if I select a number, it's going to reduce 50, 49, 48, 47, 46, 45, which would be 50P6. When I deal cards, that's C. Committee is the same as subcommittee, so these would be C. Just make sure you do 2 separate problems, right? Actually, it's kind of interesting. The first one is C, but then we're electing these things, so that would be P. So make sure you understand the difference between part A and part B. When you pick a horse, if you're just selecting those horses in the first part, how many outcomes are there in a pick 3? Well, every time you pick one of the 3, you're picking 8 factorial, but in a possible outcomes for an exacta in which you care about the race happening, that would be a P. This is a committee problem in which you're choosing from different sets. So you actually have 2 separate C's. You have a C for men and a C for women. And so in this problem, how many ways can 5 people be selected? So the first one is just one of them. And then the second one would be a C times a C, selecting from men and women. Down here at local election, that's going to be P. And then here you have identical elements. I kind of circle back to the beginning. You have 8 identical monkeys and 8 identical elephants and 5 identical monkeys. The total is 13, so you have that. But if I switch it so that the elephants are different, it would be 8 factorial, but then the monkeys have identical. So again, separate problems. You do separate problems and connect with multiplication. These problems are difficult. Critical reading and trying to get the key words out is what I would recommend. Please make sure that you're highlighting your questions, and making sure that, like, for instance, when I read part A here, it says different outcomes of an election. Election is P, right? I mean, try to look for those key words. That is the key to doing it. And then circle back to, it's got to be one of these 6 things. I hope this helped.